Displacement, velocity and acceleration. You should be aware of the following from your methods course. If we have displacement and we want velocity, we're going to differentiate. If we have velocity and we want acceleration, we're going to differentiate. And that's indicated by this arrow just here. To go from displacement to velocity to acceleration, we are going to differentiate. Since integration is the reverse process, to go from acceleration to velocity to displacement, we're just going to integrate. Between the time t equals a and t equals b, it's worth noting the following. If you do the integral from a to b of v of t dt, that represents the change in displacement. Now remember, let's say your thing starts here, and then it goes out to this point and comes back a bit. The change in displacement is this here, which could be positive or negative, depending on where the object starts and finishes. So if it started here, went out and came back here, that displacement would be negative. Therefore, if you take the modulus of that, that represents the magnitude of the change in displacement. So it will give it to you without the sign. However, if you take the modulus of the velocity before doing the integral, what that does is it makes sure that velocity is always positive. So your velocity time graph might go like that, but by taking modulus of velocity, it goes like that, and therefore it considers it to always be travelling in a positive direction. So therefore that represents the distance travelled along the path traced. This one is really useful, both in this course and in your methods course.